everyone, my name is Mohammad Shafi. I'm a graduate from West Pilani, and from the last 7 years I'm working with IT firms. Currently I'm working with an organization in Bombay in India. I'm a Cloudera certified Hadoop developer as well as the administrator. So this is in short about me. This is the training we are conducting from the last many years on Hadoop technology. So in this today's demo session, we will brief you about what the technology is, and then we will talk about how we are going to deal with the technology. And then if you have any more queries, we will take at the end of the session. Okay, let us start. So to go ahead, first let us understand some of the terminologies. The data explosion. What is data explosion? A lot of data that is entering into our machines. So for that purpose, to understand this term, let us compare 1975 arena and today's era, 2014. If you see here, some figures are given. Cost of 1 terabyte of data storage was costing me almost 1100 crore rupees that time. I can get it for less than 5000 rupees. And if you see, this is the 250 MB data storage at that time, and this is 1 TB data storage. So if you just observe this 250 MB into 40, it becomes 1 terabyte. So this much of data storage space I am getting in very portable way as well as in very cheaper way. And that time the number of network hosts are approximately 50, but today we have more than a billion network hosts, and total world's digital data that time it is approximately 130 gigabyte. Means you can hold whole world's digital data in 1/10 of your hard disk, in 1/10 of today's hard disk. But today we are moving towards almost 5 zettabyte of data. So let us understand the data measures. So as you know, the data measures start from 1 byte. Next becomes it is KB, 1 kilobyte. Next you have the next data measure is 1 megabyte. Next gigabyte. Next you have terabyte. Most of us know up to 1 terabyte. Some of you may know up to 1 petabyte also. After that, what are the data measures? We don't know because we never dealt with this much of data. But today the world is heading towards more amount of data. Next comes exabyte. Next comes zettabyte. So I'm saying that currently we are at 5 zettabyte point, and one zettabyte is equal to 1 billion terabytes. You know, total world population is approximately 7 terabytes. Sorry, approximately 7 billion. So if you take this, approximately one person is generating average 1 terabyte of data. So that is huge. And of course, the next data measures are petabyte and gigabyte. These are very huge in number, but soon we are heading towards these data measures also. So here, if you take today, we are at 5 terabyte location, but this is not fixed. Soon we are moving to 1 exabyte because the IBM statistics says within 2 years we are going to generate 90% more data. So this is the data of 2014. By 2016 we are going to generate 90% more of the data, and this data is going to be only 10% of it. So we should develop a system which can handle this much of data. So what are the data sources which are generating this much of data? As you know, we are today having a lot of social networking sites, a lot of websites which are generating the data, like social networking site, like e-commerce site, So all these are giving us a lot of data to store into the system in the digital format. And some other examples, RFID readers. If we go to the office, how we are giving the attendance. If you go to some location, so everywhere you have been tracked. So everybody is tracking you from Google, from video cams, from the external sources, from various sources you have been captured. So all this data will be stored in some digital servers. If you go to a traffic area, definitely there will be a government assisted camera will be there. So it is capturing continuously 24 hours. So all this data needs to be stored somewhere, and whenever we want particular data, I want it very fast. One more statistic. So here if you observe, in 2003, one person is connected to 0.08 machines. So if you see here, 2003, 0.08 machines per person. Means 8 machines for 100. Means 4 machines for 50 people. Okay. In 2003, which is a matter of just 10-12 years, we were 4 machines were used by 50 people. If you observe today's scenario, in 2015, one person is using almost 4 machines. So I can say that the data is growing at 50 times faster. And if you observe by 2020, one person will be connected to 7 machines. So it is going to double. If you see the mobile phones, so the mobile phones are not just for making a call today. They are useful for any number of purposes. We are generating a lot of data from our mobiles also. So by combining all this data, which is in the structured format, semi-structured format, unstructured format, we call it as big data. So all the digital data, I can call it as structured data. You know, the data that is in the row column format, like RDBMS data. Unstructured data, any data that is in the multimedia format, videos, images, all this comes under the unstructured data. And semi-structured data. Semi-structured data is like Excel sheet, which is in the middle of structured and unstructured. In Excel sheet, I can have some structure, but is it as simple as like querying RDBMS? No. So it needs some additional maintenance. So that is why Excel sheet data, I can call it as semi-structured data. Text file data. In the text file, you can store with the comma separated or space separated like that. But it is not easily queryable. So that is why even the text file I can call it as semi-structured data. So let us come back to the definition of big data. All the digital data that is available machines, and it has become a challenge for traditional systems. So what are these traditional systems? Currently we are using RDBMS. RDBMS like Oracle or SQL Server, all these are the RDBMS which has become a challenge for these systems. I can easily process the structured data with RDBMS. Can I process unstructured data with RDBMS? It is not easier. So that is why this has become a challenge for the traditional system. So we call this as big data. But this definition also has become a traditional definition for big data. So what is the current definition for big data? Big data's definition was given by IBM like 3 V's plus V. So what are these three V's? First V stands for value, second V stands for velocity, and third V variety. So as I already explained, we have today a lot of data in our systems. So that is why it is the value is the characteristic of big data. Next, velocity. Velocity with how much speed the data is entering into our machines. So let me give an example. For Facebook, per day 1 petabyte of data is loading into the system. So this is the velocity of Facebook scaling. Okay. So how much speed the data is loading into the systems, that is the property related to velocity. And the third V is variety. So variety means different types of data. My system should be ready to take any type of data. What are the types? Structured, semi-structured, and unstructured. So your system should be ready to handle any type of data. If we take RDBMS, it can deal only with the structured data. So RDBMS cannot handle big data. And what about this fourth V? The fourth V stands for veracity. What is veracity? The consistency of data. How much correct your data is. So that is what the veracity. Fourth V is the challenge for big data. So let me give a small example for this. Let us say I have projected some numbers with this much of data. Let us say election result. So exit polls. So during the elections, we will be getting the exit polls. So I have figured out some numbers for every party. So with this much amount of data. And the other person figured out the exit poll with this much of data. So in this case, who will be more accurate to the real world? The person who used more amount of data. So he will be more accurate to the real time scenario. Why? Because he dealt with more amount of data. So big data refers to better decisions. So better decisions you will be getting through huge amount of data. But the problem here is, in this small amount of data, we will be having some incorrect data, because we may get some incorrect data when we are going for a survey, or when we are going for to collect some data. So there will be some incorrect data in this small amount of data. If you take this big amount of data also, definitely you will be having inconsistency, so incorrectness of the data. So where this will be more, the incorrect data will be more with the big data. So that is the challenge to our developer. So this veracity talks about the correctness of data. So how we are going to handle this correctness? We will be writing various programs or various scripts to handle this fourth challenge. Okay, this is about big data. So let me summarize what we learned for big data. First, I have given the traditional definition, all the digital data which has become a challenge to the traditional systems, we call it as big data. And later I have given another definition. It is 3 V's plus V: volume, velocity, variety. And the fourth V is veracity, which is a challenge for big data developers. Okay, let us come back to our PPT. So why should I care about this big data when I can handle this data very effectively with the RDBMS? But our RDBMS can handle only the structured data, which is less than 20% of the data today we have, and more than 80% is the semi-structured or unstructured data. So RDBMS cannot handle this. Not only this, we have one more reason. I have a huge amount of data with me. I want point of information to be accessed very much faster. This is also not possible with the traditional systems because every RDBMS will be having some limitations. It cannot handle beyond this particular amount of data. So that is why we are in the search of a new technology which can handle this. So we are saying that Hadoop is the solution for all these queries. Let us observe why Hadoop is the solution. First and foremost important feature is it's an open source. Open source means it is freely available and you can download the code, you can change it according to your requirements. So definitely it's an advantage if something is an open source because it is freely available. If I want to install SQL Server, I have to take the licenses from Microsoft. If I have to install Oracle, I have to take the licenses from Oracle. May cost lakhs or crores. So that is why these open source systems are more preferred. And the Hadoop technology is written in Java. What is the advantage of writing a program in Java? It is most compatible with many of the platforms. So I can take the advantage of all that with my Hadoop, and it is optimized to handle massive amounts of data through parallelism. So before understanding this line, let me brief you about the Hadoop's history. First, let me take some concepts from computer science, distributed computing and parallel computing. What are these topics? These are the computer science concepts. I will explain in short way. So let's see. This is the data that I have. And to process this data, I want to process this data with some task. And this may take approximately 60 minutes to process this much of data. So instead of this, what I am going to do now is I will divide this data into 3 smaller parts and I will write such a task which can handle every part of the data. So in this case, within how much time I can complete the job? Within 20 minutes. Okay. So by dividing my data into pieces, and executing the task parallelly, I can complete it in 1/3 of the time. So if I divide my data into 60 parts, within how much time I can complete? In 1 minute I can complete. So that is what these two concepts talks about. Distributed computing means cutting your data into pieces and distributing among n number of machines. I divided my data into 3 pieces here and set them on 3 different machines. And parallel computing talks about writing such a task which can work parallelly. So this is the advantage of distributed computing and parallel computing. In 2003-2004, Google has released 2 white papers on these concepts. The 2 white papers are GFS and MR. So GFS based on distributed computing technology, distributed computing concept. MR is based on parallel computing concept. The GFS means Google File System. MR means Map Radio. Okay, GFS uses this, MR uses this. And during the same time, another person was struggling to build a open source search engine. The person name is Doug Cutting. Doug Cutting was trying to build an open source search engine, but he could not be able to optimize it. So he referred these 2 white papers. After referring these 2 white papers, he came out with an idea. So that idea is building a distributed computing technology. That is Hadoop. So Hadoop has the parents from Google, which are based on the GFS and MR. As I told, Hadoop is based on GFS and MR. So definitely Hadoop also should have these two concepts. So what he named them, he named it as HDFS. Instead of Google file system, he just removed the name of Google. He named it as Hadoop Distributed File System. And MR, here there is no Google, that is why he kept as it is. So Hadoop is having two core components, those are HDFS and MapReduce. HDFS based on distributed computing and MapReduce based on parallel computing technology. So this is about Hadoop's history in short. Most of you already know why the name Hadoop has been given. So Hadoop is his dog cutting son's toy elephant. His son's toy elephant name. So he felt this name is very unique. That is why he has given the name. So now in this we understood that Hadoop has come into the picture from two concepts of computer science. Those are distributed computing and parallel computing. Distributed computing is dividing your data into pieces and setting up on different machines. Parallel computing is writing a parallel task. Now if you read this statement, you can easily understand now. I can process massive amounts of data through parallelism. Let me put it again. I can process massive amount of data through what is parallelism? MapReduce is the parallelism concept here. So how we are processing massive amounts of data first? First we will divide the data. Okay. Next, a variety of data. Hadoop is not specific to structured or unstructured data. It is for anything. You can put anything on the top. And inexpensive commodity computing technology. This is the most important for any organization. So if you need Oracle to be installed in your machines, you need high-end hardware. But to install Hadoop, you can go for cheaper hardware. There is no issues with that. Okay, using inexpensive commodity computing. Commodity computing means whatever you have, you can work with it. You take Windows 8, it needs some hardware upgradations. But here, this doesn't need any of your hardware to upgrade. So you can work as it is. So there is no additional cost for any organization which is adopting Hadoop. Great performance. As I told in this case, if I divide the data into 60 pieces, I will be getting the work done in just 1 minute. And reliability through fair replication factor. Reliability through fair replication factor. Here in Hadoop, whatever file you upload, that will make Hadoop will make 2 more additional copies. So total, you will be having 3 copies of the same data. So if 1 copy of the data is not available, so how do we feel in case of RDBMS? In case of RDBMS, if the data is crashed, so you have to go for data recovery. So data recovery may take additional time. But in case of Hadoop, if 1 data copy is not available, the other copy is available. Immediately you can access. There is no downtime for Hadoop. But in case of RDBMS, you may have downtime if your data is crashed. So that is the reliability here. So here is the Hadoop's timeline. First, thanks to Google because they provided these 2 white papers, GFS and MapReduce. And second, thanks to this person who worked on those white papers and came out with the product Hadoop. And third, thanks to Yahoo because Doug Cutting and his team approached Yahoo to provide infrastructural support, because as I said here, I can cut my data into 60 pieces. If I cut my data into 60 pieces, I have to put the pieces on, I have to put the data pieces on 60 different machines. So I need to have a more amount of hardware. As an individual, I may not be able to afford it financially. That is why he went to Yahoo, and there he developed most of this product. But finally, they released it as Apache's product so that we are getting it for free. So this is the timeline of Hadoop. In 2011, for the first time, Hadoop has been tested on IBM Watson machine. So IBM Watson is a supercomputer from IBM. So this is a game. In this game, the middle one is the machine and rest of the two people are the players. So in this game, the anchor will give you the keywords. Based on that keywords, you have to form a question. If you see here, you can see the questions whatever they formed from the keywords. So based on the quality of the question you framed and the response time, so based on these two, you will be getting the credit over here. So if you observe here, for the same question, these two people got $1,000 and $5,600, but the machine got $17,800. And in total, the other two guys could not made at least 1/3 of what machine made here. Why I am comparing these two guys? Because the first guy is a 6-time winner of this game, and the last guy is the all-time winner of this game. But still, they could not make at least 1/3 of what machine made. You can observe how responsive, how fast responsive it is. And as you know, these are the topmost organizations which are more successful by using the Hadoop technology. Amazon, Facebook, AOL, Yahoo, name in the UK. So all these organizations are using Hadoop technology in their infrastructural setup. Okay. So this is the Hadoop ecosystem. Ecosystem in general, ecosystem means me and my surrounding. In the same way, Hadoop's surrounding. So what are the core parts as we already discussed? It is about HDFS and MapReduce. HDFS deals with how to distribute your data. MapReduce deals with the programming to process the data. But you can see most of the people who are working with large amount of data, they will be more comfortable with SQL. But if I tell them to write the programs may not be so effective. So this MapReduce can be done only in Java, Python, C++. This is completely programming. So most of the people say, I can't write a program. I don't want to write a program because I am a SQL developer, or I'm not comfortable with programming. In this case, that is why there are multiple projects that have been generated from multiple organizations. If you take Hive is a product from Facebook. So this is exactly like a SQL. If you can write SQL, you are almost 60 to 70% done with Hive. HBase is also a kind of SQL, NoSQL. You might have heard about NoSQL. So HBase is a kind of NoSQL. And Pig is a kind of SQL. So all these are SQL-like programs, SQL-like technologies. Hive, HBase, Pig, Joker. Using these, you can easily with Hadoop. How you can interact with Hadoop using these? So let me draw a simple diagram here. So here I have HDFS, and on the top you have MapReduce. So this is MapReduce. Here it is HDFS, MapReduce, and here it is HDFS. So in general, what happens? I'm going to write a MapReduce program, and this MapReduce program will be submitted to HDFS, and you will get the output. But If we have Hive, Pig, or any of these SQL-like projects, let's say this is Hive. So in Hive, as I told, it is a SQL-like technology. So I will be writing queries in SQL. So these queries will be converted directly into MapReduce programs. This is how Hive works. The same way Pig, the same way Jockey. So all these are SQL-like technologies where we developers will be writing the queries, and that queries will be turned into MapReduce program. Why they should be converted into MapReduce programs? Because MapReduce is parallel computing technology. We are going to utilize that parallel processing advantage through our queries by interacting with MapReduce. So all these are SQL-like technology. Next we have Woozy. Woozy is a scheduler. I have developed a n number of programs. Now I want to schedule them. First program 2 should run. Next program 1 should run. So how I can control this execution? By using Woozy, you can control this execution. Next we have Scoop and Flow. These are the data movement technology. Currently my organization is using RDBMS. Now my organization decided to move to Hadoop. So I have to move along with my data. So this Scoop and Flow will help me to move the data from one data source into Hadoop. So these are the various related projects we have. And next, you heard about Cloudera, you heard about Hortonworks, like various distributions. So what are these distributions? First, let me tell you what is Apache Hadoop. So as I told you, Hadoop is a product from Apache, which is an open source. It is freely available. General assumption is if something is freely available, it may not be very beautiful. So Apache's Hadoop is also same. So you don't have very good interface to interact with Hadoop through Apache Hadoop. So that is why various vendors come into the picture and they beautified the product and they made the interaction with Hadoop technology very easier. So that is where all these distributions come into the picture. Cloudera, Hortonworks, MapR, all these are the various distributions. Okay, this is about Hadoop ecosystem. So let me summarize this. The default core concepts are HDFS and MapReduce. HDFS talks about how to divide your data. MapReduce talks about how to process your data using programs. And that is why we have developed various SQL-like technologies. Those comes under Hive, HBase, Pig, Jockey. And Woozy is a scheduler. Scoop and Flume are for data movement. And we have various distributions that are available. Apache Hadoop, Hortonworks, MapR, Intel, Cloudera, many are there. And we will be covering in the training some advanced big data technologies on Mahout, Spark, Storm. So Mahout is a data mining library, and Spark is also similar to MapReduce but faster than MapReduce. Minimum 10 times faster than MapReduce. And Storm is for real-time processing. So real-time processing means Hadoop supports only batch-oriented processing. I have 10 files which are of huge size. So to process this much amount of data, you can expect at least 20-30 minutes. So if you allow this much of time, then only Hadoop is perfect. So what about the cases if I want to do real-time processing like transactions, like bank transactions? It should happen immediately, but it is not possible with Hadoop. That is why there are other technologies on the top of Hadoop for real-time processing. Storm is one among them. Of course, this is the only trending technology in the big data currently for real-time process. So what we provide in the training, we will provide all these things as part of our training. So we will provide you online training, and all the needed software will be installed in your machines. All the PPTs and hands-on exercises will be shared. Whatever I will be showing you in the hands-on exercises, that will be given to you in the form of PDFs. So, soft copies will be provided to you. So soft copies of various books which are very good books, and I will share you how you have to read that books also, because we can get many books online for free also, but we should know how to read them. So that is all provided, and individual learning plan. So based on your profile, will teach you how you have to go ahead, and personalized feedback, pre-designed schedule, and the mock interview. Whenever you have an interview, any interview has been scheduled, so that in that case you can call to us and we will schedule a mock interview for you on this technology. So you can contact us anytime, 24/7 support is available. At the end, you will be getting a certificate from our side. Modes of training, as I already did with our team will talk about the modes of training. And these are the topmost organizations which are looking for Hadoopers. And of course, these are the topmost next level companies also adopting the technology from the last 2 years. So you will have a lot amount of vacancies and requirement for Hadoop technology today. Here I will close the demo part. Now we can have any questions if you can ask. If you have any questions, you can ask me now.
So Krishnam Naidu, shall I unmute yourself? You can speak to faculty now if you have any questions. Krishnam Naidu, Chowdhury, please raise your hand if you have any questions. Guys, please raise your hand, or you can just put in the chat window if you have any questions. Mr. Balakrishna, Mr. Ranav, Krishnam Naidu, Mr. Naren, Mr. Pankaj. Yeah, 1 minute. Mr. Rebel, you can speak to me now. Rebel, you can speak to faculty now. RUBAL, Rebel, you can speak to the faculty now. You are unmuted. Okay. And Mr. Anwar, you have any queries? Unmuted, buddy. You can put any questions that you have. So I hope Safi, nobody is having any query. So
Okay.
can we plan like you can ask some questions like maybe student will answer?
So first question is what is big data?
Who wanted to answer it can raise their hand. Guys who wanted to answer this, please raise your hand. Balakrishna, can you answer it? Pankaj. Yeah, Pankaj, you can speak to the faculty now. You are unmuted, buddy. Pankaj, you can speak to the faculty now. Balakrishna. Mr. Naren, you can.
Hello. Big data is nothing but a very large amount of data. It is not possible to process with on-hand database systems.
So what type of data available in our machines right now? What are the various forms of data?
Structured data, unstructured data.
Okay. And semi-structured data. Okay, very good. Now I have spoken about 3 V's plus V. So what are these 3 V's and V?
Volume, velocity, veracity.
Volume, velocity,
Veracity,
right?
veracity.
Right. Volume, velocity, variety, and veracity. So these are various for big data. Hadoop consists of 4 parts. What are those 4 parts? There are 2 core parts. What are those? The core parts of Hadoop are HDFS and MapReduce.
So, guys, any more question? We wanted to end up this session now. Okay, guys.
Hello.
Yeah, you can
Yes,
see
yes,
the faculty.
So actually, I want to know what is the privacy in the big data.
Okay, security. So currently,
right.
currently the security is being dealt with the Linux systems Kerberos. Okay. So the Kerberos are taking care of the security.
Okay.
Of course, in the soon it may be having the advantage with other tools also. But right now, only the Linux Kerberos are taking care of it.
Okay, sir. Sir, I have one more question. Actually, I am working on my thesis that is on the geotag privacy.
Okay.
So, will you tell me how I can remove the geotag from the picture while downloading in big data?
Geotag and
Geotag picture. Actually, I have to remove the geotag in the photo, from the photo while downloading the picture.
okay.
So, how I can move that? Which technology I have to use for that?
Okay, so whatever the data that you are loading into HDFS, it is just a file. So you can take all the things as a file only. And once the file is loaded into HDFS, there we are going to use either MapReduce or Hive or Pig based on the data that we have. So as you said, it is geotag. It will be dealt by using any of these technologies. You can use MapReduce, or that is programming, or Pig or Hive. So all these are supported.
Thank you, Rebel. And does anybody has any queries? Because I just wanted to take the control and with the permission of faculty and wanted to show the course content through our website. So shall I, Mr. Shafi, can I take the control?
Yes. Proceed.
Okay, so fine. So I'll just mute off with Shafi, or Shafi you can mute from your end.
Okay.
Great. So I'll just change my presenter to myself so I can. So guys, are you able to see my screen, everybody? Can I have a small acknowledgement from your end? Just a small acknowledgement from your end in the chat window, please. Okay, so great, great guys, great guys. So I just wanted to pull off my website. Actually, this is the website name called kerneltraining.com, where you can go for all courses. Now in Hadoop, we do have three things. That's called Hadoop administration, Hadoop development, and Hadoop admin and development. So you can just come down here and you can see what is the difference between the course content which is provided. Let me show an example on Hadoop development, administration and development. This is a 50 hours of course where if you just go into that, you can have the course curriculum which is given in the left side panel, where you can see the total module which would be covered for the Hadoop completely. It's nothing but administration part, even for the development part also completely included in this part of the area. So you can see and you can glance and you can see like is it fitting for your particular area. You can go for this training on the particular things. Okay, so this is one of the part, and you can also glance the other trainings whatever we are going to give you. Let me also show you the other part of the area like Hadoop administration part. So when people go for the Hadoop administration or development or any other part, they'll be having this the part for Hadoop administrator. You can also see the course curriculum which is mentioned here, where you can have a glance on it and you can also go for it. It is just 25 hours of duration where you can go for administrator. If you wanted to go for development, it is for 35 hours, and if you wanted to take both, you'll have a common scenario where you can complete in 50 hours, where you can have weekday sessions and weekend session. And after this session, now you'll be getting a call where you would be identified where you can go for a weekdays or weekend match. So this is one of the part of the course content, and the other most what I wanted to give you a help is people who had enrolled by paying the amount, they will be getting a login ID and password. For example, I have a login ID. 1 minute, I'll just log in into this. Let me log in into this. Let me put up the password here. The registered students will be getting, okay, the registered students will be getting an user ID and password. Okay, There was something wrong, I hope. Let me check out from our end. Where they would be getting a privilege to attend the LMS. So LMS is one of the part where they can just go ahead and where all the trainings, whatever you take up, right, there's all the recorded sessions will be kept down there where you can view it anytime after your sessions has been completed also. Okay, so guys, and anyway, I'll leave an email in regards to this LMS to the participant because we are running out of time with the other classes. So I'll just stop with this. So guys, any more queries you have, you can just put up a last. No, okay, Naren. No, thank you, Naren. And I thank Safi to give this wonderful speech to us. And